6.1, right?
Yes, sir.
Today we shall be doing exercise. Actually, we did 6.2. Today we did 6.2. So, have you completed the questions? Have you done some questions from that exercise?
Yes, sir.
Do you
I
have
did.
any
I did a few.
doubts?
No, sir. I understood.
Okay. Any doubts?
No
Okay.
doubts.
So we'll be doing 6.3 today.
Okay.
That is about tangent and normal. Okay. Tangent
Okay.
and normal. So we have in exercise 6.3, what we do, we find the derivative of the function, okay, as usual. And then if the slope has to be found out, so point would be given. Suppose we have to find the slope at x equals to 2, x equals to 3, or any constant. Then we just put the value of x in the dy by dx, and we get the slope of tangent. And what about slope of normal? So slope of tangent is dy over dx. Therefore, slope of normal. Therefore, slope of normal will be what? Minus dx upon dy. Why is that? Because if we consider a curve, suppose this is the tangent at point x equals to x1. Okay. Then at this point of contact, normal will be the perpendicular line. Normal will be the line perpendicular to the tangent at point of contact. Okay. So if this is tangent, so this will be the normal. And if the slope of tangent is m, then what will be the slope of normal? Negative 1 upon m. Suppose the slope of this tangent is m, then slope of this line will be minus 1 upon m. Okay. And so we find the slope. In some cases, slope will be given and we need to find the points on the curve. So basically two types of questions are being asked. Type 1, to find the slope of tangent. Is the
Yes.
board
Yes, sir.
visible to you clearly? To find the slope of tangent and normal at a given point. Okay, at given point. And another one, type 2, to find the points on the curve, the points, point or points, okay, on the curve, when slope is given. Slope is given. Either the slope will be given or there will be some to find the slope of the tangent. Okay,
Yeah.
or normal, whatever. Type 3, to find the equation, to find the equation of tangent and normal at given points or slope, where slope is given, where slope is given. Okay, where slope is given.
Okay.
So we will be doing these three types of questions are being asked, in fact, in the board examination as well as the
Yeah.
competitive examinations. Now we'll be doing exercise 6.3. Okay, exercise 6. So turn over the page for exercise 6.3 and we'll be doing first question. Question number 1. Okay, question number 1. We have find the slope of the tangent to the curve y equals to 3x to the power 4, 3x to the power 4 minus 4x at x equals to 4. Okay, at x equals to 4. So first of all, what we have to do, we will find the derivative. Okay, so differentiating with respect to x. So we will have dy upon dx equals to 4 3 12x cube minus 4. Okay, and we have to find the slope at x equals to 4. Okay, at this point. So this will be dy by dx at x equals to 4. We will have 12 into 4 cube minus 4. That comes to 768 minus 4 equals to 764 actually. Okay, so this will be 764. So it was quite easier one. Now question number 4. Question number 4. Question 4 is find the slope of the tangent to the curve. Okay, y equals to this at the point whose coordinate x coordinate is 3. So equation of curve is given as y equals to we have x cube minus 3x plus 2. Okay, x cube minus 3x and plus 2. Okay,
Yeah.
so finding dy by dx first. So dy by dx equals to 3x square minus 3. Okay, so at the point whose coordinate is 3, x coordinate is 3. So if x coordinate is 3, then we have dy by dx at x equals to 3. Okay, so this will be 3 into 3 squared minus 3 gives us 27 minus 3. So this will be 24. Okay, so slope is 24. Question number 5 as well. Question number 5. Find the slope of the normal to the curve x equals to a cos cube theta, x equals to a cos cube theta, okay, and y equals to, we have y equals to a sine cube theta, a sine cube theta, okay. So finding dx by d theta first, dx upon d theta equals to a times 3 cos square theta into minus sine theta. Why minus sine theta, Samar?
Where chain rule. Differentiation of, yeah.
Chain rule, yes. So we have, yes, we have 3 minus 3a cos square theta into sine theta. Okay, this will be there. And from here we have dy by d theta, equals to 3a sine square theta into cos theta, Okay, so finding dy by dx, dy over dx. So this will be dy upon d theta and dx upon d theta. Okay, dx upon d theta. And this will be 3 times a sine square theta cos theta and divided by 3 times a minus 3 times a, okay, minus 3a cos square theta into sine theta. So 3a got cancelled, cos theta got cancelled, sine theta as usual got cancelled. Okay, so we have actually sine theta upon cos theta, and that comes to tan theta. Okay,
Yeah.
so we have to find dy dx at theta equals to pi by 4. So dy by dx at theta equals to pi by 4, pi upon 4. So this will be 10 pi by 4 equals to 1. So this will be, this is the tangent of what? And the slope of the normal to the curve.
Normal.
This is the slope of what? Tangent. Okay. This is not the answer. So we have to find actually slope of normal. Slope of normal. Therefore, slope of normal will be
Yeah.
what? Minus 1. So this should be the answer.
Okay.
Question number 5 we did. So now question number 8.
Okay.
And would you be able to do rest of the questions, or still you have problem? You can ask me more questions if you require.
So
Okay, else we'll be doing question number 8. Yeah,
yeah, eighth one, sir. I don't know how to do the eighth one. They give points.
Okay. Yes, yes. So question 8. Find a point on the curve y equals to x minus 2 whole square. So we have y equals to x minus 2 whole square. Okay, and at which the tangent is parallel to the chord. Okay, so first of all we have to differentiate with respect to x. Okay, we have to differentiate with respect to x. Participate the whole thing into 2 parts. That will be better. Okay, we do the participate. So y equals to x minus 2 whole square, and differentiating with respect to x. So we have dy upon dx equals to 2 times x minus 2 into derivative of x minus 2 is what? 1. So we have actually 2 times x minus 2. Okay, which is 2x minus 4. And it's given that slope is tangent is parallel to the chord. Okay, so take this one. Since this tangent is parallel to the chord this tangent is parallel to the chord joining joining 20 and 44. 20 and 44.
Yeah.
Okay, so we have slope of this chord, slope of the chord, slope of equals to the slope of tangent, because they are parallel. Okay, slope of tangent. What is the concept? The concept is if 2 lines are parallel, then their slope are equal.
Yeah.
That you studied in class 11. Okay, if 2 lines are parallel, then their slopes are equal. So slope of the chord will be what? Can you tell me what is the slope? How can you determine the slope
Yeah,
of a
we
line
need to do
joining 2
y2
points?
minus y. Yeah, by
Minus
x2
y1. Yes, yes.
minus x1.
So, yes. We have actually. Oh no. This is not. We have y2 minus y1. We have y2 minus y1 equals divided by x2 minus x1 equals to slope. Okay. So y2 minus y1, that is 4 minus 0 upon 4 minus 2. Okay, 4 minus 0 upon 4 minus 2. So this will be 4 minus 0 upon 4 minus 2. So this becomes 4 upon 2 equals to 2. So put this value, therefore, from 1, this is a little bit lighter. Let me take another pencil. Okay, so from 1 we have 2x minus 4 equals to 2 equals to actually 3. Okay, and put the value of x into the curve, equation of curve. So therefore y equals to what? X minus 2 whole square means 3 minus 2 whole square equals to 1. Therefore, point on the curve. Okay. Therefore, hence the curve, point on the curve equals to 3, 1. This will be the point. Check your answer as well.
Okay.
Okay.
Yes, sir. Answer is correct.
Now doing question number 10 and 12.
Okay.
Okay. Many questions are there. This exercise, so many questions are there. So question number 10 we'll be doing. So question number 10. Find the equation of all lines having slope -1 that are tangent to the curve y equals to 1 upon x minus 1. So we have y equals to 1 upon x minus 1. Okay, and x does not equal to. So first we will be doing the same thing, differentiating with respect to x. With respect to x, we get dy by dx equals to minus x minus 1 whole square. So student asked me, sir, how did you do this directly? So need not to use quotient rule over here. Derivative of 1 upon x is negative 1 upon x square. So derivative of 1 upon x minus 1 is negative 1 upon x minus 1 square.
Okay.
Okay.
Yeah.
And it's given that slope is -1. It's given that it's given slope equals to -1. Therefore, we have -1 upon x minus 1 whole square, x minus 1 whole square equals to -1. So minus got cancelled. Okay, minus got cancelled. So this will be x minus 1 whole square equals to 1, which comes to x square minus 2x plus 1 equals to 1. So 1 got cancelled, this will be 0 over here. So we have x square minus 2x equals to 0. And here we can take the common, x common can be taken. So x minus 2 equal to 0. So we x equals to 0 or x equals to
2.
Okay, x equals to 0.
Yeah.
So accordingly, we will find the value of y. Okay, so y equals to what? 1 upon x minus 1. So 1 upon 0 minus 1 is minus 1, and comma 1 upon 2 minus 1, which is 1. So points are 0 comma minus 1 and 1 comma 2. Okay. This should be the answer.
Sir, how did you get the y coordinates?
Just put the value of x in the equation of curve.
Okay.
Okay. The points, where are the points? Points are on the curve.
Yeah.
So we definitely will put the value of x in the equation of curve. Okay.
Okay.
Now question number 12 we will be doing. Okay. So question number 12 now. Question 12. Find the equations of all lines having slope 0 which are tangent to the curve. Having slope 0 which are tangent to the curve y equals to this. Okay. So y equals to we have y equals to 1 upon x square minus 2x plus 3. Okay. So derivative, we will find the derivative of this one, differentiating with respect to x. So we will have dy upon dx equals to minus 1 upon x square minus 2x plus 3 whole square into derivative of this function x square minus 2x plus 3. So this will be 2x. So we multiply 2x minus 2, and this will give us minus 2x minus 1. Okay, and here it is x square minus 2x plus 3 whole square. Okay, now slope is find the equation of all lines having slope 0. It's given that slope is equal to 0. So it's given that that slope is slope of all lines. Slope of all lines. Slope of all lines equals to, therefore dy upon dx, which implies minus 2 x minus 1 equals to 0, which implies x equals to 1. Okay?
Yeah.
So we got x equals to 1, and then we put y equals to y 1 upon 1 minus 2 plus, which gives 1 upon 2. So, and the point on the curve, the point on the curve equals to 1 comma 1 upon 2.
Yeah.
Okay. So we shall find the equations of all lines. So equation of line at 1 comma. So equation of line passing through 1 comma 1 by 2, having slope 1 comma 1 by 2. Okay, having slope 1 comma 1 by 2. So we have y minus having slope 1 comma, okay, slope is given something else. Okay, slope is what? 0. Slope is 0. And if slope is 0, then equation will be y equals to half. Okay, if the slope is 0, then equation will be y equals to half. So this will be y equals to half. How it is? See, equation of line is what? Y minus y1. Y1 is half equals to m. M is 0, x minus 1. So actually this is 0. So this gives half. But I have some doubt in the answer. So check your answer, because I think the point that we have mistaken. So check your answer.
Yes, sir. It's correct. It's y is equal to 1 by 2.
Okay, that's correct. Great. Okay. So Samarth,
Yes, sir.
now we'll be doing the question. We did 12. Okay.
Okay.
13. We'll be doing yes, 13. and 15.
Okay.
13 and 17. Question number. So, question number 30. Find points on the curve x square upon 9 plus y square upon 16 equals to 1, at which the tangent are parallel to x-axis. First part, tangent is parallel to x-axis. If the tangent is parallel to x-axis, then dy by dx should be equal to 0. Okay. So first find the derivative. Derivative will be 2x upon 9 plus 2y upon 16 dy upon dx equals to 0. And which gives y equals to, this 2 will be cancelled out actually. So minus x by 9 minus x by 9 and 16 by 9. Okay. So this will be 16 by 9 minus 16 upon 9 and x upon y. Okay. So equal to 0. Because the slope is, so dy by dx. Dy by dx is, okay. So dy by dx
Sir, I have one doubt.
Yes.
Sir, why did you apply chain rule to?
Ask me.
Why did you?
Yes, ask
Yes, sir,
me.
I'm asking. Why did you apply chain rule to y square by 16?
Because we are finding derivative with respect to differentiating with respect to x.
Yeah.
Okay. So if we put x equals to 0, then we have y equals to plus minus 4. Then points on the curve points on the curve will be 0 plus minus 4. Okay. And if it is parallel to y-axis, if it is parallel to y-axis, then we have y equals to 0. If equals to 0, which gives x equals to 9. So x equals to what? Plus minus 3. So points on the curve. So points on the curve. Points on the curve will be plus minus 3, comma 0.
Yes, sir.
This will be the answer. Take your answer. Come on.
Yes, sir. It's correct.
Question number 17. Find the points on the curve y equals to x cube. Y equals to x cube, at which the slope of the tangent is equal to equal to y coordinate of the point. Okay. So to find the slope, we have dy dx equals to 3x square. Then it's given that slope is equal to y coordinate of the since slope is equal to the y coordinate equal to the y coordinate of the point. Therefore, and y is what? X cube 3x square, which implies x cube minus 3x square equals to 0, which implies x square x minus 3 equals to 0. Okay, so x equals to 0 or x equals to 3. These points are there. X equals to 0 or x equals to 3. Now, we need to find y coordinate. So y equals to x cube means 0. Y equals to 3 cube 27. So points are 0, 0 and 3 comma 27. Okay, these are points. We have to find the point on the curve. So these will be the points. Can you do 2 questions? One from question number 6, one to question number 6, another 11, not 11, actually. Yes, 11 and 14.
Okay.
14, any parts.
Yeah.
Okay. So you can try question number 6, 11, 14.
Okay.